Hey there, science fans. Today we're diving into the exciting world of spray deposition. What is spray deposition, you ask? Well, imagine this. You have a can of spray paint, but instead of just changing the color of your fence, you're actually building up thin layers of amazing materials. That's spray deposition in a nutshell. Spray deposition is a powerful technique used in many different fields. It allows us to create thin films and coatings with incredible precision. From solar cells that power our homes to protective coatings that make our gadgets last longer, spray deposition is changing the way we live and work. But how does it actually work? Well, it all starts with a liquid solution containing the material we want to deposit. This solution is then turned into a fine spray, kind of like how a perfume bottle creates a mist. The tiny droplets in the spray travel through the air and land on a surface where they stick together and form a thin film. In the following sections, we'll explore the fascinating applications of spray deposition, delve deeper into the step-by-step process, and uncover the advantages that make it such a game changer. So buckle up and get ready for a wild ride through the world of spray deposition. Spray deposition is like a superhero with a secret identity. It's used in so many different fields you might not even realize it's there. One of its most important applications is in the world of renewable energy. Solar cells, which convert sunlight into electricity, rely on thin films of materials like silicon. Spray deposition provides a cost-effective and efficient way to create these films, making solar energy more accessible to everyone. But wait, there's more. Spray deposition is also used to create super strong coatings that protect surfaces from wear and tear. Think about your smartphone screen. It's probably coated with a thin film that makes it scratch resistant. That's right, spray deposition is protecting your precious phone. And it doesn't stop there. Spray deposition plays a vital role in the medical field too. It's used to coat medical implants with biocompatible materials that won't be rejected by the body. This technology is helping to improve the lives of countless people around the world. From solar cells to smartphone screens and medical implants, spray deposition is everywhere, quietly making our lives better in countless ways. Now that we've seen what spray deposition can do, let's take a closer look at the process itself. Don't worry, it's not as complicated as it sounds. In fact, we can break it down into three main steps: atomization, transportation, and deposition. First up, we have atomization. This is where we take our liquid solution containing the desired material and turn it into a fine spray. There are different ways to do this, but the basic idea is to break the liquid down into tiny droplets. Think of it like using a spray bottle to water your plants. You're essentially creating a mist of water droplets. Once we have our spray of droplets, we need to transport them to the surface where we want to create our coating. This is typically done using a carrier gas like air or nitrogen. The gas helps to carry the droplets to their destination and ensures they're evenly distributed. Finally, we have deposition. This is where the magic happens. The droplets in the spray land on the surface and stick together, gradually building up a thin film layer by layer. The thickness of the film can be controlled by adjusting the spraying time and the concentration of the solution. In the next three sections, we'll explore each of these steps in more detail, so stay tuned. Remember those tiny droplets we talked about? Well, atomization is all about creating them. It's like taking a big pitcher of lemonade and turning it into a refreshing mist on a hot summer day. There are a few different ways to achieve atomization, but one common method is using ultrasonic vibrations. Imagine a tiny hammer tapping on the surface of the liquid really, really fast. That's kind of what's happening during ultrasonic atomization. The vibrations create waves that break the liquid up into those super small droplets we need. Another popular method is called air atomization. This one's pretty straightforward. We use a stream of high-speed air to blast the liquid into tiny pieces. It's like using a powerful hairdryer to create a fine mist of water. No matter which method we choose, the goal of atomization is the same: to create a spray of droplets that are small and uniform in size. That way we can ensure that our coating is smooth and even. Section 5, Step 2, Transportation, guiding the droplets to their destination. Okay, so now we've got our tiny droplets of material all ready to go, but how do we get them from the atomizer to the surface we want to coat. That's where transportation comes in. Think of it like a delivery service for our droplets. We need a way to carefully transport them to their destination without losing any along the way. This is usually done using a carrier gas like air or nitrogen. The carrier gas acts like a gentle breeze, carrying the droplets along with it. By controlling the flow rate and direction of the gas, we can make sure that the droplets are evenly distributed over the surface we're coating. Transportation might seem like a small step, but it's crucial for creating a high-quality coating. Without proper transportation, our droplets could end up all over the place, resulting in a messy and uneven film. Section 6, Step 3, Deposition. Building up the coating layer by layer. We've atomized our material, transported our droplets, and now it's time for the grand finale, deposition. This is where our tiny droplets finally reach their destination and start to build up that thin film we've been talking about. Imagine each droplet as a tiny building block. As the droplets land on the surface, they stick together and start to form a layer. We keep spraying more and more droplets, and slowly but surely, the layer gets thicker and thicker. The amazing thing about spray deposition is that we can control the thickness of the film with incredible precision. We can create films that are only a few nanometers thick. That's thinner than a human hair. And because we're building up the film layer by layer, we can create complex structures and patterns with ease. It's like using a three-dimensional printer, but instead of plastic, we're using atoms and molecules. Section 7, the advantages of spray deposition, why it's a game changer. Now that we understand the ins and outs of spray deposition, let's talk about why it's such a big deal. Compared to other coating methods, spray deposition has a lot going for it. First of all, it's incredibly versatile. We can use it to deposit a wide range of materials, from metals and ceramics to polymers and composites. This opens up a world of possibilities for creating new and innovative products. Secondly, spray deposition is very efficient. We don't waste a lot of material during the process, which is good for the environment and our wallets. Plus, it's a relatively fast process, which means we can produce coatings quickly and efficiently. Thirdly, spray deposition allows us to create coatings that are extremely thin and uniform. This is important for many applications, such as in electronics and optics, where even the slightest imperfection can affect performance. Last but not least, spray deposition is a relatively low-temperature process. This means we can use it to coat heat-sensitive materials without damaging them. Section 8. The future of spray deposition. Even more exciting applications. As technology continues to advance, so too does the potential of spray deposition. Researchers and engineers are constantly finding new and innovative ways to use this versatile technique. One exciting area of research is in the field of flexible electronics. Imagine being able to print electronic circuits directly onto bendable surfaces like fabric or plastic. Spray deposition could make this a reality, paving the way for flexible smartphones, wearable sensors, and even electronic skin. Another promising application is in the development of new energy storage devices. Spray deposition could be used to create high-performance batteries and supercapacitors with improved energy density and lifespan. This could revolutionize the way we power everything from electric vehicles to portable electronics. And let's not forget about the medical field. Spray deposition is already being used to create biocompatible coatings for implants and drug delivery systems. In the future, it could even be used to create artificial organs and tissues, offering new hope to patients in need of transplants. Section 9. Conclusion: spray deposition, a versatile technique for the modern world. From solar cells and smartphone screens to medical implants and beyond, spray deposition is quietly revolutionizing the way we live, work, and interact with the world around us. Its versatility, efficiency, and ability to create thin, uniform coatings make it an indispensable tool in a wide range of industries. As we've explored in this journey through the world of spray deposition, this powerful technique has the potential to shape the future in countless ways. From flexible electronics and advanced energy storage to life-saving medical devices, the possibilities are limited only by our imagination. So the next time you see a solar panel soaking up the sun's rays or marvel at the clarity of your smartphone screen, remember the incredible science of spray deposition that made it all possible.